Chapter 4, question 11, is asking you, would you use the atomic number? So that's the first thing. The mass number, that would be a second thing, or both, to determine each of the following. So before we dive into this problem, let's talk about what each of those things is. Now, if you look on any box on the periodic table, there should be at least 3 things inside of it. The first one is a symbol. That should be in the middle of the box. Then there should be a number on top of that, and there should also be a number on the bottom. The number on the top is called the atomic number because that is the number that determines whether what an atom is, what element it is, what type of atom it is. The physical meaning behind the atomic number is it's the number of protons that are in the nucleus of that atom. And it makes the atom the element that it is. So for example, anything that has 6 protons is carbon. Doesn't matter how many neutrons it has, doesn't matter how many electrons it has, nothing else matters. If there are 6 protons, it is a carbon atom. So the number of protons determines what type of atom something is. So it's the atomic number. And that's the number on the top of the box on the periodic table. The number on the bottom of the box in the periodic table is called the mass number. And it's the mass number because it tells you the mass of the atom. Now, the mass of the atom comes from the protons and the neutrons, each of those weighing 1 atomic mass unit. So, really, the number on the bottom is the number of protons plus the number of neutrons. That's the number on the bottom, the mass number. Okay, so now we can go back and look at each of these things. Now, if we wanted to know in A, we want to know the number of protons in an atom, what would we look at? We would look at the atomic number. So we would write the atomic number. That's what we would use to find the number of protons in an atom, the number at the top of the box in the periodic table. For B, it says the number of neutrons in an atom. Well, neither of these numbers is just the number of neutrons. But what you can do is you can take the mass number, and remember the mass number is the number of protons. I'll just use P here, plus the number of neutrons, I'll just use N. You can take the mass number and you can subtract the atomic number. So the number on the bottom minus the number on the top. Remember, the atomic number is the number of protons. So if you take the number of protons plus the number of neutrons and subtract the number of protons, you're just left with the number of neutrons. And so if you wanted the number of neutrons, you would have to use both the mass number and the atomic number. So you would have to use the mass number and the atomic number in order to find the number of neutrons in an atom. For C, they ask about the number of particles in the nucleus. Now, the nucleus only has protons and neutrons, but all of the protons and neutrons are there. So how many particles are there in the nucleus? However many protons and neutrons you have, and that's given to you by the mass number. So all you would need for this is the mass number. The mass number. The mass number tells you the number of protons and the number of neutrons. The number of protons and neutrons, that's all the particles there are in the nucleus. For D, they ask you about the number of electrons in a neutral atom, and the word neutral is crucial here. Remember that protons have a positive charge and electrons have a negative charge. So if the atom overall is neutral, then the number of protons must equal the number of electrons. If you had more protons, then it would be positive, not neutral. If you had more electrons, then it would be negative, not neutral. In order for the atom to be neutral, the number of protons has to equal the number of electrons. So in a neutral atom, if you're looking for the number of electrons, well, all you need to know is the number of protons, and it'll be the same. The number that tells you the number of protons is the atomic number. The atomic number tells you the number of protons. So you would only have to use that number in order to figure out the number of electrons in a neutral atom, because the number of protons and the number of electrons in that case would be the same.